Happy to be here. I hope you can bear with me for half hour, 40 minutes on English. My name is Bela. I'm a management consultant at Arthur D. Little. Arthur D. Little is a classical management consultancy. Our typical competitors are likes of McKinsey, Bain, and BCG, and so on. But what is different for us is that we link strategy a bit more to technology and to innovation and to transformation. So we believe we are a bit more technologically apt than some of our competitors. And I'm here to share a few of the insights that we have collected over the past few years on how digitalization on the one hand drives forward and what that means for our digital infrastructures. So let's get right into it. First, digitization revenues clearly is projected by, I think, all consultancies around the planet to be growing significantly faster than most other industries. What is to be, what we show here on the chart is the overall value that is being created, and that's why I guess digital is on everybody's agenda. But what people often forget is that digital is really, it's a topic that is different for each of the industries. So what we did was we looked at the industries, covered 35 reports, went through 400 use cases. As consultants, we're a bit nerdish about this, right? We go and we don't stop until it's complete, and went through all of the sizing. And here's what we came out with. Clearly, digitization is fast already, but it's going to accelerate. And the biggest industries where we see this accelerating is in the energy and utilities, it is in the manufacturing, it is in financial services, in public safety, and then the rest. So many of you will be familiar with this, but there's something that we learned. And what we learned is digitization does not happen in industries. It's not an industrial change. It actually happens in very individual and specific applications. And that's what I want to talk with you about, because that's where the real thing happens. So we looked at 35 industries, we collected 400 use cases, we grouped them into 8 clusters. I have a few with me. Let's look at how they work. Here's one example. This is a grocery retail store operating in the UK, and as you can see, they have these little robots that sort of go on these tracks, and underneath the tracks is where you have the goods and the produce, like so, and then the robots will pick out the products and transport them back to wherever the packaging station is. I want you on the next picture to look at the sheer size of this installation. Look at how far back this goes. This is huge. There's multiple factories like that out there. Another version of that is doing vertical climbing. They have 400, they do 400 picks an hour. They carry 30 kilos of weight. If you do 400 picks an hour, that is faster than any human will ever be able to do, right? And they don't work on rails, they work on concrete floors. Transport things to wherever the packaging station is. Again, look at the packaging density in the background. And then, you know, the next level up of this is, of course, not only work on rails and so on, but carry the entire rack. These little things, again, they don't travel on rails. They actually carry 500 kilos, carrying the entire stack. This is a Chinese installation, but there's multiple of them already available around the world. So my point with this is only logistics, and we have a video on airports, and we have a video on mining, and we have one for retail, and many different examples. The point of all this is, if you digitize in logistics, and we all know logistics is a narrow margin, right? It's a 3%, 5%, 7% profit margin. With solutions like that, you take out 70% of the cost, right? That's where the value has been created. Another example, from condition-based maintenance to predictive maintenance with optical sensors. Very often, when you think of the classical maintenance that we do, the sensors that we deploy, they're all fairly simple sensors. They will measure temperature, vibration, location, things like that. Take it to optical, all of a sudden you have a very different computational problem. You have a very different networking problem. Think of smart meters, taking that to virtual power plants. We all know that smart meters are out there, and maybe it's a business, maybe not. It's definitely not a big business. But the moment you make this a critical infrastructure by linking it up with your power generation and your power consumption, if this is 5% of the grid, it's fine. If this is 30% of the grid, it becomes critical infrastructure. Again, the way that you handle information, data, your network, your security, your computing becomes a lot more complex. From stadiums, and this is a nice example actually. I need to get my phone to illustrate this. This is a nice example of Telstra in Australia, and also Chelsea is following up in the UK. What they did was they said, well, you know, we have 20 video cameras in our stadium, and that's all great, and we all backhaul them to some editing room. Can we not have Wi-Fi in the stadium? And then Telstra said, sure, well, I'll give you Wi-Fi, but I'll give you an app as well. And then the people sitting inside the stadium, they can have any of the 20 video cameras on their smartphone. The reason why they can do that is because they have the 20 video streams, right? Because that's what they backhaul, and because they control the quality of service on the Wi-Fi. But if I give you an app, I will add a button for popcorn and one for Coke, and I'll display the information on the queue length of the toilet, right? Relevant. So then they said, so if I can do the popcorn and Coke, I'll do the in-venue navigation, and I'll make sure the guys who carry the popcorn and Coke, they go to those places where there's the highest demand, right? But if I can do in-venue navigation, I will sell premium parking spaces for my stadiums, right? To when the guests arrive, they will be at the entrance, and then they will navigate to where their premium parking space is. But if I can sell tickets for premium parking spaces, I can sell tickets to the next show. So I do the ticketing, the body cams, the surveillance, the crowd control, etc. Then Telstra added another 40 video cameras. So now we have 60 to 80 video cameras in these stadiums. They're not all on the side. It's body cams on athletes who will also take biometrics, right? So now we have a screen where we can pick any camera in the stadium, and we will have superimposed how far did the guy run, how much, you know, what's his biometrics, how much battery has he got left, etc., right on the smartphone, augmenting the overall stadium experience. The next step is to take that entire thing to outside the stadium. So you have 30,000 people in the stadium, and then you have another 10,000 in public viewing spaces, following the same experience, right? That's where you create value. That's where digitalization helps. From single sensors like that to more complex sensors that actually take care of machinery and health and safety and life, essentially, to even flood control. That's an image of the New Orleans flooding, where it was really important to understand where to send the emergency crowds, because floods is happening everywhere, but you don't know how much, right? So clearly, as you push forward, things evolve. Now, there's a big question. I want to talk to you about that very briefly, which is all about your 5G. 5G is clearly a big thing in the industry in many places. And I want to demystify 5G a bit so that we get back to what is real, right? In 5G, there's a myth out there that 5G will produce 1 million devices per square kilometer. It'll have 500 kilometers per hour. It'll produce up to 10 gigabits of speed. It'll have a very high reliability and low energy consumption, all that sort of stuff. Let's look at these things one by one, okay? Energy consumption. If we're saying we want 1/10 of energy consumption for 1,000 times the traffic, it means we need to be 10,000 times more efficient. That'll come, but not on day one. It'll need to evolve a little bit, okay? If we want 99.999% availability of a 5G network, that means for 100,000 cells, we have loss of 1 cell for a few seconds, okay? So yes, that may come one day, but definitely not on day one. If we want 1 million devices per square kilometer, that's fine, but if we look at the most densely populated city in the world, Manila, for Manila it means 24 devices in everybody's pocket. Yeah, maybe, but maybe not on day one, right? Maybe that'll so, and we can go on for the 1 to 10 gigabit data rate. Let's be clear, the LTE today delivers something of 10, 20, 40, something like that, megabit, right? If we move that to 1 gigabit, that would be equivalent to watching a 32K video, right? You know HD, then there's 4K, 8K, 16K, 32K, right? Watching a 32, it doesn't make a whole lot of sense to do that. Moving to 10 gigabit is even, right, less sensible, and so on. So there's a lot of myth in there, and I think we need to be clear on why 5G is relevant. And some of the digitization use cases that I've shown you, as they progress from what they are today, like the smart meters into virtual power plants, clearly they will require 5G, but that's some time away from enterprise networking point of view, and it will be based on very simple things. First, executive focus, executives who invest into networking and computing technology will not invest into the last generation. They'll invest into the new generation, right? That's an argument that actually hits home a lot more than all the performance KPIs I gave you earlier. Device density. There's Wi-Fi is not sufficient for the number of devices that we have. It'll move into 5G. Bandwidth. If we do, like I showed you earlier, if we go from sensors to video or radar, LiDAR, X-ray type of things, then we'll need the bandwidth, and so on. So it's important to understand. I have a video with me here to show you how 5G can be used as a digital infrastructure component, and then we'll talk about the strategic factor a bit. So this is how your 5G network is being delivered. Okay, you get a box like you do from Amazon, right? You unpack. You have your radio unit. You have a little what is called an edge gateway, antennas, SIM cards, right? And then basically you mount it like you would a Wi-Fi system. Now let me share you the costs of this, so you have a view. This antenna can cost something between $3,000 and $5,000 depending on range. If you go for the high end, it'll have 40-watt output power. That's a lot, right? By any means, and it will do 4 channels of 40 watt. Obviously, there are smaller antennas as well. You plug it all in, connect it to the edge gateway, which means that data now stays on your campus. It doesn't go back into the mobile network and then via fiber, right? It stays where it is. You switch it on. The device calls home into an Amazon Web Services cloud, which you'll see in a second, right there. Registers itself. We have all of the core platforms in Amazon Web Services right where you have your IT, and then clearly you can install your SIM card and put it into your device. In this case it's a phone, but it could as well be any kind of machinery. So what this is, it's a solution by a company called Atonet, sitting in AWS, and Ruckus Wireless for the wireless piece. The nice thing about it is that your digital infrastructure can be now sitting in Amazon Web Services as well. Or it can be sitting in your own data center on-prem, right? And I think that's an important part. So let's talk a little bit about the strategic backdrop of all of the things that I've given to you. We have researched over the past 2 years what we call future enterprise networking, and it's talking about the convergence of computing and security and networking and how that changes. It is based on a few dozen interviews that we've held with CIOs of big companies and authored in this report. The report stipulates that over the next 5 years we're going to have 5 to 10 times the traffic volume that we have today, right? That sounds a lot, but it's the natural progression. We've had that for the last 5 years as well, okay? We're going to have more than 7 clouds in our production. Already today we have 5. Right? So on average, enterprises produce in multiple cloud environments, both public and private, roughly half-half. Right? That'll be 5. That'll be going to 7. And we'll have a lot more devices, clearly, as you've seen. The reason why this is relevant for enterprise is because a lot of that traffic hits enterprises, and enterprises are faced with a demand of handling those requests, both computationally, security-wise, and from a networking perspective. So CIOs think about 3 things. How do I move data through time? That's called storage. How do I move data through space? That's called routing. How do I transform data? That's called computing. And they need to do that not only in their infrastructure sphere. I'll walk you through this chart a bit. Out here we have the use cases on the outer edge, right? Then we have the locations. Then we have the access networks. Then we have our transport networks. Then we have our data centers and our cloud. Okay? That's the normal setup that from the outside to the inside. The issue that CIOs have is they are responsible often for the infrastructure. This is the cost downside, right? You need to save money. Digitization happens out here. This is where you have the value plus, right? So the business units with their use cases, that's where the money is. But CIOs aren't responsible for the business units. They're responsible for the cost down. And the real issue is CIOs are also responsible for securing the use cases. Imagine that you have goggles in your warehouse. Imagine somebody hacks the goggles, right? The next thing is the guy's in your ERP. You don't want to have that happen. So you got to secure. So the security parameter is out here, but he's under cost pressure. That's when a shadow IT emerges. That's when business units start to do their own IT, right? And it's because these use cases are out here and they're attractive. I've given you the figures, 70% cost savings in logistics. Guess what? The guys are going to go after that. It's very simple, right? So there's the stretch here. So there's 5 things, and we won't talk about all of them, also for light of time, that lead to rethinking the digital infrastructure. 1, cloud, multi-cloud environments, important. If your production distributes, it changes things. Parallel computing, agile development, new use cases emerging, and then a new role for IT departments that we envision and that we see and happy to share about. First, I already said the number of cloud production environments is increasing. We're at 4.7 in 2018. I expect this to go to 7 in the next year. Why is that relevant? That is relevant because if you look at how much data is being managed inside a data center versus how much data is on your network, right? So traffic going to the data center versus traffic inside the data center, it is at least 25 times, right? At least. If you have machine learning and other things, it'll be 100 times. The issue is you put that into multiple environments, you have 100 times on your network, right? That's the issue. If you want to provide an instantaneous experience to your customers, you got to handle that volume on your network or design your cloud architecture so you don't run into this problem. Second issue, companies want to increase the velocity with which they deploy software. Today, around 50% of companies, that's the light blue bars, deploy either biannually or quarterly, and they have classic release cycles, right? 50% want to, in a few years from now, do it weekly, right? How can you do it weekly as you go through your development from planning, coding, integrating, testing, releasing, and deploying? Every single time you have manual intervention. You have to automate, right? You have to automate deployment. You cannot go to weekly. This is where your infrastructure gets in the way of your digital ambitions. If you deploy biannually, you will not be moving fast enough. So manual doesn't work anymore. It's got to be automatic. Security, big topic, network and cybersecurity, right? If you change your infrastructure setup and your application setup weekly, and you have a segmented network, for those of you who don't know what a segmented network is, you have different applications with dedicated spaces in your network. Say that you have, I don't know, 100 networking devices or 500 networking devices. You have 20 segments. Boom. You want to configure that manually? It's got to be automatic. How do you do security if you operate in 5 clouds? Your security parameter runs through the 5 clouds, right? Can't do it differently. Big topic. The do-it-yourself approach that we see today is not going to continue to work. It'll need professional support. Otherwise, your digital infrastructure is at jeopardy. And at jeopardy means it's not anymore a question of if you will have a security incident, it's a question of when, right? Finally, what I want to raise with you is the changing role of IT departments. In the past, IT departments were really providers of technology, right? And of services. That role is changing. That's changing to a system integrator role. And I want to tell you what that means. That means that IT departments have customers, internal customers, right? Who expect, because they are used to that from their iPhones and things, and or smartphones, right? They expect to have some form of a digital portal, right? Where they can order things and monitor things and raise tickets and get feedback and so on. So the IT unit needs to provide an order management, an incident management, a quality management, service catalog, a number of other things for their internal customers. But their suppliers need to do that too, right? Let's take an example. Surveillance camera. So customer orders a surveillance camera, right? Surveillance camera is 4 services. It's the device. It's somebody who goes out and installs it physically. It's the connection to the camera, right? And it is the configuration into the monitoring software, okay? As an example. So actually you have 4 vendors. Does it matter to your customer when the device will arrive on site? No. Irrelevant. It only matters when is the service there. So the IT unit actually needs a catalog that segments the internal service into their suppliers and aggregates the information back. It's a very different role than what IT does today. Automating IT and integrating IT. I call it IT for IT. is a big topic. Otherwise, your customers are going to be unhappy with the service you get, and if that's the case, they'll put pressure on your costs, and you're back to square zero where you're an infrastructure part, cost down, value up is in the shadow IT. Okay? So how do people buy? I already hinted to it. We interviewed them. The most important aspect is automatability. Can I automatically provision, configure, monitor, manage my IT stacks, my network, my security policies in an integrated fashion? So we've captured some of that thinking in our latest report that was launched in February, because a lot of digitization actually is happening with in a campus context on-prem, and that's available on download on our website. If you want, then what is new is for providing digital infrastructure is that we're so far in your local area networks on your campuses, you only have Wi-Fi and wireline. What is new is cellular is becoming available, both with private LTE and with 5G. You can have, for your companies, you can have your own cellular network. The examples I've shown you before were 4G networks that made those use cases possible, right? It's not possible on Wi-Fi for a number of reasons. And that's a new evolution. You see in many European countries a big discussion about that, with BMW lobbying with the German regulator and BASF and Daimler and a number of others, with ABB, Siemens and so on getting in to go for spectrum, with the US launching some spectrum. There's some debates in Switzerland, in France, in the UK. How can we make cellular available to enterprises in a campus context? What that means is that we're going to have still an on-prem data center, and we're going to have local area networks, and all the applications that need higher performance or higher security are going to sit here. I'll give you an example, right? That doesn't mean that things will not also go into the public cloud. That will continue, right? But there's things coming back from the public cloud for a number of reasons. What that means is we will have computing functions, storage functions, and security functions in our local area network. The things converge. Again, my security camera example. Imagine you have 150 security cameras on your main train station in Zagreb, right? Do you want to, or maybe 100 or 50, whatever it is, right? Do you want to backhaul 100 HD video streams to some cloud where you have the video analytics? No, you don't, right? You want the analytics software to run where the cameras sit, because it doesn't make sense, right? So you want to put whatever you have here to here. That's what I'm talking about. Networks take computing workloads, and they'll continue to do so. And that's an important change. I already mentioned a few of the companies. Spectrum is becoming available. You can get that from operators, you can get it from regulators, you can get it from equipment vendors, you can get it from system integrators. I know system integrators who actually go for Spectrum to provide such networks. To give you an idea, there is hundreds of these private networks deployed already. So we're talking about 5G deployment. I tell you what, there's hundreds of them out there. It's just not from the big operators, because the big operators don't see the business case that businesses have. They don't see the business case that system integrators have, right? But we know mining, ports, stadiums, airports, railway operators, refineries, manufacturing, logistics, all of these companies are deploying private networks. We have collected over 300 case studies. Our estimate is that there's something between 3,000 and 4,000 of these networks in operation already. With that, I'd like to close. I hope I could give you a bit of an insight on where the future is heading in the digital infrastructure space. Any questions, I'll be around. Thank you for your attention.